Good morning or good afternoon. I am 9 students, depending on what time of the day it is. You probably just finished your formative quiz on the exponential unit. Well, let's dive a little deeper into exponentials. What we're going to learn today is transformations with exponentials. Transformations mean moving or transforming an exponential. How we're going to do that is on a coordinate plane, on a graph, using a table. So please write down your learning target. The learning target is I can transform exponential functions vertically, which is up and down, and horizontally, which is left and right. So we have been practicing graphing exponentials, but now we're going to shift and transform those exponential functions. Let's go ahead and try this. Remember, you can pause the video at any time, just in case you need to go back and clarify something, or ask your teacher a question to clarify, or take some notes. The more detailed notes you do, the better this will be for you to reference back to. Let's go ahead and try this. Well, before we start moving graphs around, we need a place to start, right? Everything starts somewhere. Well, so do people. People are a product, okay? They come from their parents. So we like to call the very first or the starting exponential the parent function. And the parent function is part of your exponential equation. Keep in mind that we are in the function unit. So f of x is also known as the y value. F of x is another way to write an equation in function notation. That's why we use the f, the letter f. So as we progress through this unit, keep in mind that f of x can also be known as the y value. And that might help you remember when creating your table, because you have an x and a y on your table. We also like to call the table the t-chart. Okay, so let's identify the parent function, the very first graph that we're going to make, and then we're going to start to transform the graphs. A parent function is a base and an exponential, and that's it. So for example, on number 1, this would be our parent function. The plus 2 is not included, okay? So I want you to get into the habit of identifying the parent function. So right here, next to parent function, let's write f of x equals 3 to the x power. Now you can fill in your table by substituting your x values into your power and calculating. 3 to the negative 2 power is 0.11. 3 to the negative 1 power is 0.33. 3 to the 0 power, and anything to the 0 power, is 1. 3 to the 1 power is 3, and 3 squared would be 9. Let's go ahead and make that graph. So I'm going to take a minute to graph these points. You can pause the video and fast forward. It's up to you, but I'm just going to take a minute to make this graph. There's my points from the table, and let's go ahead and connect to make an exponential function. Let's label this appropriately because we are going to be changing it or transforming it. Let's label this graph f of x. That's the original or the parent function. The transformed function includes the plus 2 from the original equation. So if you look over here, I'm going to highlight it. The entire green highlighter is the transformed function. Let's write that over here to the right. Now, when you are changing something, essentially you're creating something new. So we use a new letter to represent a new equation. So over here, we're going to represent that with g of x. And the transformed function is 3 to the power of x plus 2. Let's fill in the table exactly how we did by substituting your x values into your power and then adding 2. I'm going to pause the video and fill in the table and then create the graph. Okay, we're back. Thank you. If you take a look, I filled in the table to the right for the transformed function, and then I created the graph in green, and I labeled it g of x. So then we knew what the original parent function was in blue and the new transformed function. Well, what do you notice? What do you notice about the blue graph to the green graph? If you're not quite sure, you could always take a look at the table. Okay, I'm going to draw a long line. Let's compare the table values. If you take a look at your tables, your x column is the same, but take notice of what happened to your y column. How did these values increase? Keep that in mind. Why don't you try the next graph on your own and see what you come up with. Once you have finished graphing, we will compare the two graphs and come up with a rule about transformations. I'm going to pause the video and let you make your own graph. And then I will go over what the solutions and what the graph should look like. Thank you for creating the graph and trying it on your own. This is what the solution should look like for your graph. Here's your table of values. So, and then I should add the parent function also. The parent function is f of x equals 2 to the x power. Remember, it doesn't include the number in the back. And your transformed function, which is in blue, is g of x equals 2x minus 3. What do you notice? What do you notice between your graph? Maybe you can notice what's happening with these values. Or with some of these values. Or if you're not sure if you created the correct graph, let's take a look at your table. What do you notice about your y values? What are the differences here? Are they consistent? I think so. What we can conclude is if there is a number in the back of your parent function, I kind of tell students on the very end, a plus or a minus, these numbers will shift or transform your graph vertically. Let's go ahead and come up with the final rule. This is a rule formation, okay, this is the whole equation, that says how your exponential can be moved. So, in conclusion, if there is a number in the back, let's say it's represented by k. If k is negative, okay, let's say like we had a negative 3, for example, number 2, your graph will shift down however many k is. So we say k units. So if you look at number 2, the parent function went from here to a negative 3. What happens is we shifted the entire graph down 3 units. If we look at number 1, we shifted the entire graph up 2 units. And that's how you create a vertical transformation. So, if k is positive, if there's a positive number, you will shift vertically up k units, however much k is on your graph. It will move your graph up and down. Let's try the horizontal transformation on page 2. I'm going to do number 1, and you are going to do number 2. I'm going to pause the video for a second and fill in both of the tables, just to make this process go a little bit faster. I'm also going to create both of the graphs in different colors, and I will label the graphs. Welcome back. I identified the parent function and the transformation function. So if you look, the parent function is f of x equals 3 to the x. Remember, it's just the base with the power. It doesn't include any other numbers. And the transformation function is g to the x equals 3 to the power of x minus 2. Keep in mind, this negative 2 now belongs or is located up in the power spot, no longer down next to the base. I also created the tables in the different colors for each the parent function and the transformed function, and I graphed both. What do we notice here? I noticed that from the original, the graph seemed to shift over. I wonder how many it shifted over. Why don't you investigate? Try number 2 on your own. Go ahead and pause the video. Try to transform this one on your own, and then I will give you the solution and we will discuss which we find. Keep in mind, I did add negative 3 to the transformation function table. I wonder why I did that. Go ahead and add that to your x values and see what happens. We'll come back here in a minute. Welcome back. If you got this correct, these are what your y values will be for the parent function. Keep in mind the parent function is f of x equals 2 to the power of x. Do not include the plus 3. Your transformed function is g of x equals 2 to the power of x plus 3. Here is the tables and the graph. The parent function is graphed f of x, and I have them labeled, and the transformed function is g of x, and I have that labeled. Now, the reason I had you add negative 3 to the x column of the transformed function is because these values were getting too big, and they were going off of your graph. And they're hard to see how the original points shifted. Let's take a look. Let's compare the parent function to the new one. What do we notice? In conclusion, if you look at the first one and the second one, and you look at the direction of my arrows from the parent function to the transformed function, you will conclude that there's a horizontal transformation, left and right shifts. That occurs when the power is being added or subtracted to a number. Not the k value, but the h value. So let's conclude. If you have a positive h, okay, if you have a plus 2, plus 3, your graph will shift, here it comes, left h units. It's backwards. If h is negative, negative 2, negative 3, negative 4, the graph will shift, here it comes, right, however much h is, h units. So we will discuss that further in class, but keep in mind, those are backwards. Okay, one last investigation. Third page. Graph the following exponential. This one looks a little different than what we've been doing. I already filled in the parent function table for you. Let's label the parent function. The parent function is actually still 3 to the x. The transformed function is g to the x negative 3 to the x. Keep in mind, this is technically negative 1 times 3 to the power of x. Okay? That will make a difference when you're typing it into your calculator to create your table. Now, speaking of that, why don't you go ahead and try it and see if you come up with the same values that I have. I'm going to go ahead and fill in my table. I'm also going to pause the video and create both graphs and label them. I have created both graphs on the coordinate plane. Holy moly! What happened? Look at the f of x compared to the g of x. What happened from the original parent to the new graph? Whoa! I notice these points are symmetric. These points are symmetric. And those points are symmetric. Look at that. It looks like those points jumped over the x-axis. Oh, I should investigate more. Let's try number 2. Number 2 is a little bit different. It looks almost identical. The parent function, f of x, equals 3 to the power of x. And the transformed function would be the new one. G of x equals 3 to the negative x. Wow. I filled in the table for the parent function. I'm going to fill in the table for the transformed function, and I will create both graphs, and we will come back together, and we will investigate. Whoa! What happened from the parent function to the new one? Take a look. I'm going to investigate. From the parent function, I noticed that 2 comma 9 is now over here at negative 2 comma 9. Whoa! And then, same thing. These ones jumped here. This one's at the same spot. These ones jumped. Whoa! Does anyone know what this is called? Yep, you guys are right. A reflection. This is reflected. If you take a look at my direction arrows, for number 1, those arrows seem to be kind of jumping over the top of the x-axis, the red line. If you look down here, these are kind of, I'll put them in red. These are kind of jumping over the top of the y-axis. Okay, so they're mirror images of each other over the top of those axes. Okay, those x and y axis, they serve as the mirror. So, how that's represented. If there is a negative sign in front of your B, okay, you will be creating a reflection over the x-axis. For example, number 1 on this page. If there is a negative sign in front of your x value, then there will be a reflection over your y-axis. Those tricky axes. Why don't you investigate further and try your homework? When you are done watching this video and filling out your note guide, please show your work to the teacher and have your teacher initial before trying your homework. Thank you for watching my video, and I hope you learned about transforming exponentials.